This map visualizes a massive logistical problem. U.S. national parks cover over 85 million acres of land, but in some states there is only a single archaeologist assigned to oversee up to 2 million acres. Because experts simply can't be everywhere at once, thousands of undocumented archaeological sites remain hidden. Most of the time, it's everyday people exploring the trails who accidentally stumble across these artifacts. The problem is what happens next. Over 90% of known Native American archaeological sites have already been destroyed or looted by treasure hunters. We desperately need the public's eyes to help find and document these historical records, but giving out exact locations guarantees they'll be stolen or ruined. If a hiker takes a picture of an arrowhead and posts it online with a GPS tag, they've just broadcasted a free treasure map to looters. Finding a ranger in millions of acres of wilderness is highly unlikely. The National Park Service does have online reporting forms, but they are long, cumbersome, and the data often gets buried without reaching a central repository. Professional survey tools like iDig and Digit exist, but they are far too complex and expensive for casual hikers to use. Researchers have tried macro-level solutions like space archaeology, using satellites to scan massive sections of the Earth to locate potential historical ruins. But commercial satellites only operate at a 30-centimeter resolution. That is far too blurry to spot small, crucial details like a piece of pottery or a chipped arrowhead on the ground. Current methods are broken. They offer massive scale without any security or high security without any scale, leaving our history incredibly vulnerable. A New Jersey robotics team called the Robo-Rovers realized they needed to build a totally new system. After consulting with software experts, they drafted a rigorous product requirement document to map out exactly how to keep users engaged while keeping artifacts safe. The result is SightSnap, a citizen science mobile application explicitly designed to bridge the gap between casual hikers and professional archaeologists. The user journey is highly controlled. If you spot something interesting, you don't touch it. You snap a photo, add a brief description, and submit it, all in under 90 seconds. Because national parks often lack cell service, the app features an offline mode. It securely caches the photos and location tags locally on your device. While offline, SightSnap runs an integrated edge AI directly on the phone to analyze the image, categorize the terrain, and pre-tag the submission before it ever connects to a network. To keep people returning to the trail, the app uses an ARC badge system, rewarding users as they move from their first discovery to a global guardian status. This solves the scale side of the problem by turning passive hikers into eager field scouts. When connecting, submissions bypass the public internet, uploading directly to a secure state database. Location masking gives experts exact coordinates while blurring public views. Sensitive mode locks down NAGPR-protected sacred items. Finally, community validation lets users verify discoveries and filter out bad data. AI curation works alongside this community filter to weed out random rocks and misidentified fragments, ensuring state databases aren't overwhelmed. This specific architecture resolves the paradox. It leverages the crowdsourced scale of millions of visitors while maintaining the strict data security required to keep artifacts in the ground. By capturing repeat photos of the same trails over time, this system allows archaeologists to remotely track early signs of site erosion and detect vandalism long before they can visit the area in person. But a crowdsourced AI model like this only works if a massive number of people actually download and use it. To drive that adoption, the Robo-Rovers are building integration partnerships with AllTrails, the National Park Service, junior ranger programs, and state historic preservation offices. Instead of a handful of isolated experts trying to survey an entire continent, we gain a connected, nationwide network of active site stewards. It builds a safe bridge between professionals and the public, allowing everyday people to experience the thrill of historical discovery without ruining the archaeological context. By turning every smartphone into a secure sensor, we can finally map the millions of acres currently left in the dark, ensuring these artifacts are studied by experts rather than lost to the public market.